Okay, today we're going to talk about graphing radical equations. So we're going to just deal with graphing square roots essentially. Okay guys, so we're going to start with the very basic y equals the square root of x. That's our parent function. Okay, so when I make my table, I have x and then y. Remember, y is just the square root of x. So I need to be kind of deliberate about what values I pick for my x values. So I need to pick perfect squares because it is the square root. So I'm going to pick 0 because then the square root of 0 is just 0. Okay. Now, another perfect square is 1 because the square root of 1 is 1. Now if I pick 2, the square root of 2 is not a perfect square, so I'm not going to pick 2. I'm going to pick my next perfect square, which would be 4. The square root of 4 is 2. Last one but not least, I'm going to do 9, because then the square root of 9 is 3. Okay, so my table is, if I kind of redo my table, it's 0, 0, 1, 1, 4, 2, and 9, 3, because I'm taking my x values and just square rooting them. Okay, so let's go ahead and plot those points. So 0, 0, 1, 1, 4, 2, and then 9, 3. Okay. Now when I go to make this graph, it's going to be kind of a curvy line, and it has just one arrow to the right. Okay, because if I think about this, we can't do square roots of negatives, so I don't have anything going to the left anymore. So my point starts right here at this dot, and it goes to the right forever. That is our parent graph for our basic function. Okay, so what we're going to do now is we're going to take that basic parent function that we have, and we'll transform it or move it around like we've done in the past. If you notice, our basic or our general form for it is exactly like we had in the past, or it looks very similar. We have y equals a, then the radical x minus h plus k. So our a value is going to our stress, compress, or reflect. Remember, it reflects if it's a negative. Okay, that's what we multiply our y column by. Our h is our horizontal shift, so our left and our right. Remember, that's going to be the opposite. Our k is our up and down shift. So I kind of put it onto the side for you, but h is adding left or right. Adding is shifting left, subtracting is shifting right. For the k value, adding is shifting up, and subtracting is shifting down. All right, so our steps, we write our table, we multiply the y column by our a, we graph those points, and then we shift them. Same steps we've all used with graphing. Okay, let's start with this first problem. Y equals 2, square root of x minus 3, and then plus 1 on the outside. Okay, so I see my a value is 2. It's in that a value spot. So that tells me when I make my table, I'm going to multiply all my y values by 2. Okay, now inside of the radical, I have that minus 3. That tells me that I'm going to go to the right 3. That plus 1 tells me that we're going to go up 1. So now when I make my table, remember, we're going to pick perfect squares for our x values. So 0, 1, 4, and 9. Now if I square root those, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay, now I need to multiply all those values by 2, since my a value is 2. So then 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. So we can kind of ignore those first y column values that we used because we don't need those anymore. We're just going to plot our x and our new y values. So first one is 0, 0. Second one is 1, 2. Next one is 4, 4. Last one is 9, 6. Okay, those are our points. Now we need to shift them to the right 3, up 1. So I'm going to take all those points and shift them to the right 3, up 1. Right 3, up 1. Right 3, up 1. And right 3, up 1. Now I'm going to go ahead and connect those dots. And like we talked earlier, the left side stops right at that stopping point, but the right side goes on forever. Now let's do this next one. So if I notice I have a negative out front, so that right away should tell me that I'm going to flip this graph or reflect this graph. Hey, remember, technically there's a -1 out there. So when I make my table, I'm going to multiply my y's by -1. I also see that there's a -5. That tells me that we're going to go to the right 5. Since it's inside of the radical, it's left to right shifting. It's an h value. So when I go to make my table, I have 0, 1, 4, 9. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Now we're going to times all those by a negative. So we have 0. We'll have -1, -2, and -3. So when I plot these points, I have 0, 0, 1, -1, 4, -2, and 9, -3. Okay, so now I need to shift all of those points to the right 5. So I'm going to go ahead and shift all of them to the right 5. And that's okay that this last point goes off. I just would go ahead and graph it like it would if it would just kind of keep going like that. You don't need to put a dot there. You just put it off the graph, and that's perfectly fine. We graph as many as that we can once we shift it. And that is our final answer. And you can notice that it's upside down, and that tells us that it had a negative a value. Okay, for this one, I actually want to change this. So we can go ahead and, instead of y equals the square root of x plus 6, we're going to change this to y equals square root of x, and then we're going to put the plus 6 on the outside. So it looks like that. Go ahead and change that onto your notes. That's perfectly fine. So it's going to be just the radical of x, then plus 6 is on the outside. It's not inside. So when I go to graph this, I'm going to make my table. Okay, there's no a value, so I don't need to multiply my y's by anything. That plus 6 on the outside tells me that we're going to go up 6. Okay, so let's go ahead and do so. So I'm going to make my table 0, 1, 4, 9. Y values would be 0, 1, 2, and 3. Now I'm going to go ahead and plot those points. 0, 0, 1, 1, 4, 2, and 9, 3. And I'm going to shift all of those points up 6. So I'm going to go up 6 from that point. And there is our graph once we shift them up 6. All right, now we're going to work backwards. We're going to write the equation of the graph, or write the equation given the graph. So we're going to use that y equals a square root of x minus h plus k. All right, so it kind of gives us the point, but we're going to look at our starting point of this graph. That's going to be our hk point. Okay, so if you look, our h is at -1 and our k is -5. So when I go ahead and write this, I'm going to y equals, leave a little bit of space, put my square root. Okay, if you notice, if we normally start at 0, 0, we went to the left 1. So that's going to be x plus 1, which makes sense. If it's x minus a -1 would be x plus 1. Okay, and then it's shifted down 5. So I'm going to put -5 for my k value. Okay, if you notice, our h was -1. Our k was -5 right here. Now our last point that sometimes throws some people off is our a value, which is essentially kind of like slope. So for our a value, it's really easy. All we're going to do is we're going to start at our starting point, and we're going to go to our next point. So if I go over 1, I only go up 1. So that tells me that my a value is just 1. And you don't have to have it there, so you could just write it as y equals the square root of x plus 1 minus 5. And there is our final answer. Okay, let's look at this one. Same thing, we use y equals a square root of x minus h plus k. If we look, if we normally start at 0, 0, I just went to the left 3 spots. I didn't go up or down at all, so that just tells me that that's just going to be our h value. So I'm going to go ahead and put y equals, leave some space, put my square root, and I'm going to put x, and it went to the left 3, so it's going to be plus 3. Okay, it didn't go up or down at all, so I don't need a k value. So now let's check to see if it has an a value. So, same thing, we start at our starting point. I go over 1, and I go up 2 to get to my next point. So since I go over 1 up 2, our A value is going to be 2. And this is our final answer. Go ahead and get started on your practice problems. Ask questions if you got them. Good job.